So in class, what we finished with is we had been working with heat of vaporization problems, and we've been working with heat of fusion problems. So I'm going to really quickly draw out your heating curve one more time. Okay, so you've got increase in temperature, flat part, increase in temperature, flat part, and then an increase in temperature. So this is your heating curve right here. And so just as a review, because your y-axis is temperature, okay, right here at the very bottom, you're going to have a solid. Then right here, you're going to have solid again. But at this flat part, at this plateau, you're going to have a liquid. Okay? And so the solid to a liquid, if you're dealing with water, that's going to occur at 0 degrees Celsius. Okay? So that's your melting point or your freezing point. Then the liquid's going to increase in temperature. It's still going to be a liquid. And then at the top of this, right here, you're going to have a gas. And so that right there, that temperature which that occurs, that's your boiling point, which would be 100 degrees Celsius. And then if that were to continue to increase in temperature, you'd still have a gas. So this is a heating curve. So the problems that I'm asking you to do before we do any calculations is, let's say, for example, I tell you you have a gas at, let's say, I tell you 110 degrees Celsius. And I want you to show what happens when it becomes, I'm going to make this one a longer one just so you can see the whole process, a solid at, I don't know, let's say negative 10 degrees Celsius. All right, so where I start is a gas at 110. So let's say it's going to be right about here because this is 100 degrees. So I'm going to say this is 110. So my first step is to go from a gas at 110 to a gas at 100 degrees Celsius. So I'm going to put this as step number 1. Okay? And if you want to write gas at 110 to gas at 100, that's perfectly fine. Your next step is to go from a gas at 100 to a liquid at 100. So this is going to be your step number 2. Okay? Then your next step is to go from a liquid at 100 degrees to a liquid at 0 degrees. So that's going to be your step 3. Okay? Then I'm going to go from a liquid at 0 degrees to a solid at 0 degrees. So that's step 4. Okay, and then the last step is going to be going from a solid at 0 degrees to a solid at, let's say, negative 10 right there. So that's going to be step number 5. And so in these problems, you actually already know how to calculate the heat that's involved in step 4 and in step 2. What you don't know how to do is to calculate the heat that's involved in step 1, 3, or 5 because you're changing temperature. But you actually do, and that's what we're going to be covering in class during your next block period. But let's really quickly review. Let's say, for example, I were to tell you that your heat of vaporization, I'm just going to make up a number, but your heat of vaporization, which would be step 2, just to review the math of this, let's say your heat of vaporization is, I don't know, I'm making up a number, 44 joules per mole. And so what I'm asking you is how much heat is required to, let's say, vaporize, I don't know, I'm going to give you 55 grams of water. Okay, so to do that, just like what we did in class, you're going to start with 55 grams of water. Okay, and so what I'm measuring is the heat required to go from here to here. So that's step 2, even though step 2 is actually the opposite of that, but we'll see how that impacts it next class. So I'm going to go from grams. Notice that my units are kilojoules per mole, so I need to get this into moles first. So I'm going to put moles on top, and I'm going to put grams on bottom. Now for every 1 mole, I have 18, this is the molar mass of water, 0.02 grams for every 1 mole. Now that I'm in moles, I can get into kilojoules by putting moles on bottom and kilojoules up top. Okay, so I'm going to put this 44 up here. This isn't actually the heat of vaporization of water. I just kind of made it up on the fly. If I were to ask for kilojoules, which I might, then you could leave it like that. But just as review, if I want to get into joules, I'm going to put kilojoules on bottom and joules up top. And there are 1,000 or 10 to the third joules in every 1 kilojoule. And so in the math that you're doing for any plateau here, it's going to be just like this. I might slightly change the numbers, obviously, but it's just using your heat of vaporization or your heat of fusion, the value that'll be given to you, and the mass to figure out how much heat total is required for that change in state of matter, either from a liquid to a gas, a solid to a liquid, etc., etc. So I would take 55, I divide it by 18.02, multiply by 44, and then multiply by 1,000, and that would give me my answer. And that's it.